ನೋಡಿ ಆನಂದಿಸಿದ್ರೆ ಅಂತ ನಾನು ತಿಳ್ಕೊಂಡಿದ್ದೀನಿ. ನನ್ಗೆ ತುಂಬಾ ಖುಷಿ ಆಯಿತು. ಕೆಲವೊಂದು ಜನಗಳ ಟ್ಯಾಲೆಂಟ್ ಅಂತ ಹೇಳ್ಬೋದು, ಅವ್ರು ನೋಡಿ ಅವ್ರ ಪುಟಾಣಿಗಳಂತ ನೃತ್ಯವಂತ ನೋಡಿ ನಂಗೆ ತುಂಬಾ ಖುಷಿ ಆಯ್ತು. ಎಲ್ಲರೂ ನಾವು ತುಂಬಾ ಎಂಜಾಯ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಆನಂದಿಸ್ತಾ ಇದೀವಿ. ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಹೀಗೆ ಆನಂದಿಸ್ಕೊಂತ ಮುಂದುವರ್ಸೋದಕ್ಕೆ ನಾವು ಇವತ್ತು ಮ್ಯಾಚ್ ಶೋ ಮಾಡಕ್ಕೆ ಬಂದಿದ್ದಾರೆ. ಸೊ ಇವ್ರ ಬಗ್ಗೆ ಫಸ್ಟ್ ನಾನು ಹೇಳ್ಬೇಕಂದ್ರೆ, ಇವರು ನಮ್ಮ ಕನ್ನಡದವರು. ಇವರು ಹೆಸರು ಶಿವಕುಮಾರ್ ಸರ್. ಸೊ ಇವರು ಫ್ರಮ್ ಗುಲ್ಬರ್ಗಾ. ಸೊ ಅಲ್ಲಿಂದ ಅವರು ಗುಲ್ಬರ್ಗಾದಿಂದ ಮುಗಿಸ್ಕೊಂಡು ಅವ್ರು ಮದ್ರಾಸ್ಗೆ PUC ಮಾಡ್ತಾರೆ. ಅಲ್ಲಿಂದ ಅವರು IIT ವಾರಣಾಸಿಗೆ ಹೋಗ್ಬಿಟ್ಟು IIT ಮುಗಿಸ್ಕೊಂಡ್ ಬರ್ತಾರೆ. ಡಿಗ್ರಿ ಕೆಮಿಕಲ್ ಇಂಜಿನಿಯರ್ಸ್ ಮಾಡ್ತಾರೆ. So from there he comes to US and do his masters and PhD degree in chemical in Texas University, and he is currently employed as a director and enterprises company in Tyson Center, Virginia. So Yuru, known as a human calculator, he can recites almost 10,000 decimal digits, and he can calculate as much as fast your calculator cannot be done. Kids, like if you want to calculate, like an example, we calculate like has like a, oh, 2 multiplication is very hard for us. Like if you say, oh, 4 ones are 4, or like 10 ones are 10, or like a 10 ones is very simple. Like 12 ones are, oh, I should use some calculator. But sir is never going to use his calculator. His brain is own calculator. He can compute with your calculator. You need to be check his calculator, like take your calculator ready, kids, and you need to ask him any question. You can give in a fraction of second. So make sure most of your question should be dropped in the chat box, and we gonna check like whoever comes the first questions, we gonna give her detail like first preference, and we gonna share with the sir. And he has a couple of agenda, like our own agenda. First they gonna provide us like a simple like ಅಂದ್ರೆ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಕೇಳ್ತಾರೆ. ನೀವು 1 like 1 to 100 like up to 99 any decimal, if you give him, he can give multiplication within a fraction of second. So kids and the families or youngsters, like you say maths is a hard, for him is a maths is a easy peasy. So it's lemon squeezy. So he gonna do is a lemon squeezy and tell you in a fraction of second how easy is a maths. So let's take inspiring from him. And he like, so from him he has a lot of sessions has given to the lot of people, and we can use that session also here and learn how he gained that knowledge, and he's ready to share that knowledge to us. And I'm really proudful and thankful to Shiva sir to join here and show us to his like talent to us and our kids and our friends. So they're gonna utilize this show for math show as like a festival or for our knowledge also. So I'll hand over to Shiva sir, so he can start this program now.
Hi, thank you, Naveen, for the wonderful introduction. I think you are very fulsome in your praise. I mean, I appreciate that. I'm not sure if I'm that deserving, but Naveen, sincerely, Naveen and Raj, many thanks for having me over, and both of you have done an amazing job of setting it up. And I also my thanks to the Kannada Hoysala Sangha at Delaware. I mean, you guys have been amazing. You invited me over to really all the everything that you have set up today. So to start off with, I'm just going to make the show very informal. It's going to be less about the calculations and things like that. Okay, I'll answer a question. You check with the calculator. More about engaging and interactive with people to give you like a basic understanding of why numbers are important. Basically, try to take you through a journey into what I call this astounding world of numbers. So maybe we'll do some calculations here and there, maybe like 40%, 50%, but bulk of it, a lot of it, not bulk of it, but much of it will also be talking to you about what numbers mean and why they are special. So the idea is to make it more interactive. We can even have like a Q&A. However you think, we'll just let the show flow as things shape up. So it doesn't have to be very formal. So a bit of introduction about myself. I started enjoying numbers from a very young age. I was about 7 years old, less than 7. They had asked us to memorize multiplication tables in school, and I started looking at that up to about 10 or 15 they had asked us to memorize. But I started with the slate, and I figured out that I could go way beyond that, and then slowly I did 22, then 35, and so on and so forth. By the time in like a week or something, it was done by about 100 digits. Up to 100, I'd already memorized the table. So I don't know how that happened, that part happened, but whatever it is, it gave me a good appreciation for numbers, and I started thinking more than trying to beat a calculator or being very fast or something. And that's certainly important. That's like a byproduct. More than that, it gave me an understanding of numbers so that I could build on that to gauge what it means to be like 1 million or 1 trillion. I mean, that is what I want you to take away from this show, rather than the speed of calculations at all, because that's a separate issue. I mean, that it's certainly important, but more important, I want you to get a good understanding of numbers as we go along. So for me, that sort of is where I started off with. I mean, the multiplication, division, and then I used to look at train timings and then figure out average speeds of trains between two stations. For instance, I grew up in Shabad, Karnataka, and I pretty much knew all the rail lines. And Shabad was centrally located close to Wadi Junction, and between Bombay and Madras, I knew all the trains. In fact, from Shabad to Gulbarga to Raichur, I still remember all the stations and the kilometers mark at which each of the stations came, plus the timings. So I started gaining an understanding of numbers. While that was more of a specific thing, it was the general picture. Really, what I wanted to give you was to take this knowledge and take it to how you can understand numbers and math. That is where I wanted to start off with. So that's my introduction in brief. So just to get a warm feeling, just to understand, and once in a while we'll do this in between. We'll talk a little bit about numbers. We'll do a show. We'll go back and forth. We'll have questions. So I think for the first act, what I thought is, I remember back in school we were asked to memorize multiplication tables, 1 to 15 or 20 at most. So I'll try to attempt something like that, but let's go way beyond 20. To make it simple, let's pick a 2-digit number. And with a 2-digit number, what I'm going to do is just before I'll wear my mask so that I'm blindfolded. And then somebody, Raj or Naveen, you can mention the 2-digit number, and I'll recite the multiplication tables of that number from 1 to 10. But instead of doing 4 times 1, 4, or 4 ones are 4, 4 twos are 8, I'll just go 4, 8, 12, 16, 20, because that way I don't spend time reciting all the extra stuff. Instead, I just get to the calculation directly. So with that, having said that, let me put on my mask. And does one of you want to give me like a 2-digit, or Naveen, you can give it to Naveen, and Naveen, you can shout out his answer.
Yeah, kids or anyone, like you, if you want, go ahead, you can type your number. So for example, I can share like 57.
You want me to start? Okay.
Yeah.
57, 114, 171, 228, 285, 342, 399, 456, 513, 570. That was 57 times 1 to 57 times 10.
Wow. Super, sir. So kids, do you want to verify? Like I have, oh, good. Like Raj has pasted the answer here, and it's amazingly perfect. I have
ನಾನು ಬಹಳ ಸ್ಲೋ ಇದ್ದೀನಿ ಆನ್ಸರ್ ಕಳಿಸ್ಲಿಕ್ಕೆ, ಸೊ ಸರ್ ಆಲ್ರೆಡಿ ಹೇಳ್ಬಿಟ್ರು.
Yes.
Another number.
Yeah. So we have a question from ROE, and she has 47, sir.
Okay. 47, 94, 141, 188, 235, 282, 329, 376, 423, 470.
Super, right, kids? So, like, see, we can cross verify if you wanted, and we have from Aruni, it's 92, sir.
92, 184, 276, 368, 460, 552, 644, 736, 828, 920.
Wow. And
give us 2 seconds, sir, before that I can taste it.
That's a good idea. So let's take from Deepika Ramesh, it's 67, sir.
67, 134, 201, 268, 335, 402, 469, 536, 603, 670.
Wow. Kids, you're looking at the chat, right? You must look at the chat and say like, okay. And So we're gonna for the 86. Sir, can you wait for like 86? You have to wait for it. Like sir, 86 multiplication. You're gonna paste the answers. We're gonna verify it slowly with the sir. Okay.
Okay.
So it's like, sir, you can start the 86 now.
Okay, 86, 172, 258, 344, 430, 516, 602, 688, 774, 860.
Wow.
Okay.
Amazing, right, kids? Oh, yeah. So,
So maybe we can move on, or if you want one more, we can do it.
We're gonna have, I think, we're
Tej
gonna have
has asked
a,
69.
Navin, there's a question from Tej. He wants to know the multiples of 47.
oh, great. Yeah, thank you.
I'll do it right now. Have you posed?
Sir, yeah, we're gonna paste the answer. Okay, now you can go ahead, sir.
47, you said.
Yes.
47, 94, 141, 188, 235, 282, 329, 376, 423, 470.
Superb. Yeah, Shantala ma'am, it's only from 1 to 99, not like 109 triple reads. So we're
I mean,
gonna have.
you can do 109 if you're interested. I can do it. 109, 218, 327, 436, 545, 654, 763, 872, 981, 1090.
Superb, sir. See, you can cross-verify. Like, sir is amazing calculator, right?
Prerna has asked for 89.
89, 178, 2. Oh, you want me to wait till you paste? Sorry.
Yes, sir. Please, sir. Please paste. Raj going to paste it. The answer. Okay. Now you go ahead, sir.
89, 178, 267, 356, 445, 534, 623, 712, 800, 801, 890.
You need to clap.
My hands are paining copy pasting.
So do you want to move on to the next activity now, or do you have one more?
We have
like
one
we don't
last.
have, yeah.
99.
99 is actually simple, but you paste it and then I'll.
So like everyone asking like how you multiply so easily like.
I'll answer the question once you paste
Okay.
99 and let me know.
Yeah, we are good in 99. Okay, go ahead, sir.
99, 198, 297, 396, 495, 594, 693, 792, 891, 990.
Superb, sir. So kids, I need to hold you for, sir. We are done for this portion. Like we have more interactive section.
Yes.
Please hold. Thanks for your question, sir. Now kids want to know like how you can teach the skills to them.
I will take this off. Okay. Memorizing numbers is something that just happened. I just started playing with it. I just started doing it. Most of it is already in memory, I guess, and some of it, if not, I just add very quickly. If you don't want to do this, you don't have to do this. If you don't want to do this, no big deal. As I said at the beginning of my show, the idea I want to communicate here is not too much that you need to do all these calculations and become an expert at all this multiplication. The idea is you need to understand. I want you to get an understanding about numbers, how what they mean. For instance, let's take the example of 47, right? In slow motion, how do I do it, right? So if you have 47, then 47 times 2 is 94. How do you get that? Multiple ways. You can just take 50 times 2 is 100 and subtract 3 times 2, that is 100 minus 6, 94. Then 47 times 3, again 50 times 3, 150, and then you can then subtract 3 times 3, that's 9. 150 minus 9, 141. So you can do that, and you don't have to follow the same method throughout. The beauty about numbers, once you get a good feel for it, is your brain automatically figures out what is the most efficient way to do this. For instance, let's say somebody asks you, what is 47 times 23? Okay, I'm just giving an example. So you immediately know 47 times 2 is 994. Then you add a 0, that's 47 times 20, 940. Then 47 times 3, 141. We just did that. So 940 plus 141, 1081. So
can you write it, sir, for kids to understand easily? That will.
Okay. All right. Hopefully you'll see this. So let's say somebody says 47 times 23. And there are multiple ways to get the answer. This is just one way. You don't have to stick with this way. So what is 47 times? What I do is 47 times 2 is 940, 94. Then I keep 47 to 2 is 94. And because I'm multiplying by 20, because I do 20 and then 3. So 94, and I add a 0 because now I multiplied it by 20. So I already have 940 stored in some corner of my memory. Now 47 times 3 is 141. We just did that. So now I already stored 940 somewhere. 940, 141, add the 2, 1081. Okay.
Super, sir. Like you're not seeing the chat session. Kids are so excited to see you now.
Thank
Now,
you. I'm here. I'm glad that they're really happy about it.
yes, yes. So, shall we move for the next step, sir? Like next trick.
Yeah. The next, and again, more so, I'll try to talk about numbers first, and rather than just do a show, do a calculation, we'll just do things in between. How many of you have heard of squares? I'm sure a lot of you have. I know. I wish this was a more interactive.
I think. Yeah, Rohi has said like they raise the hand.
In a real world, once COVID is done, we would do this in front of an audience. It's a lot more interactive, but let's do the best we can. So square is number multiplied by itself, correct? Okay. Like 4 squared is 4 times 4, 16. 5 squared is 5 times 5, 25. 7 squared is 7 times 7, 49. So the squares are actually a very important property because have you heard of Pythagoras theorem? Some of you are going to school in geometry, right angle triangle, right?
Yes.
So you know this. You have a triangle, okay? And I'm not a very good teacher. My wife Soumya is actually, she teaches math. She's excellent when it comes to teaching. I just talk something and I just go away, but bear with me, I'll try to teach. So this is a triangle. So if I put, if this side is 5, so, I'll make it simpler. If this side is 3, this side is 4, do you know what this hypotenuse is? How do you calculate it?
Like what? Yeah.
It is square root of 3 squared plus 4 squared, which is 9 plus 16. Square root of 25 is 5. Right? So one of the basic place where squares are used is Pythagoras theorem. Or I give you a square. You're playing in the you want to construct a square fence or something, and somebody comes to you and asks you like, okay, what is the area of the place of the lot that you want to construct a fence? And you know you have a square area, roughly, you think it's a square, and you roughly estimate that it is 6 feet. Each side is 6 feet by 6 feet, 6 feet by 6 feet. So what is the area of this square? 6 times 6, 6 square, 36, correct? 36 square feet, right? So that is where squares are important. Squares are very they are a very crucial mathematics. So a lot of you have come up with the answer. I see a lot of answers, which is very good. Okay. So what we will do in this one is we will actually give me like a 2-digit number. I will try to square it, and I'll just maybe already take your calculator, calculate it, and I'll keep my mask on, and I'll try to we'll do like 3 or 4 of these, and we'll see what answer whether the answers match with the calculator. Okay, let's do a 2-digit number. So pick one.
Sorry, sir. I was in the mute. Okay, sorry. 88, sir.
88 square is 7744.
Okay, so we'll cross verify. Okay, a lot of questions now. I'll go by 63.
63 square is 3969.
3969. So Gaurav, it's 76.
76 square is 5776.
Oh, super.
So Naveen, 1 second, sorry. There are a few more questions there. I just want to make sure that the kids are heard. 42.
42 square is 1764.
All right. Shantala's 88.
88, I think somebody asked. It's 7744. So how do you, I mean, and maybe we can do one more and I can explain how to square a number, right?
Yeah. We're gonna take Akhilesh Honnur is 98.
98 square is 9604.
9604. Oh,
There's
Let me
63 and 23. 63.
63 square is 3969.
super, right? So guys, you need to hold on, like Tej or everything, like anybody chatting. So sir gonna answer like how he came, like solve that square root. So
Perfect. Okay. Shall I remove a mask? Okay.
yes, sir. Yeah, please.
Oh, great. So fortunately, many of the squares I actually remember, so I didn't have to calculate that much, but some of them I did. So there are multiple ways in which you can calculate squares. And for those of you who know algebra, you know that a plus b whole square equals a square plus 2ab plus b square. Or if you want to subtract and do, if it's a number that's closer to the if you think it's better to subtract a smaller number, then a minus b whole square is a square minus 2ab plus b square. So let's take the example that somebody gave, right? So 63 square, all right? So 63 square, you can split it up as 60 plus 3 square, correct? Right? Correct? So this will be 60 square plus, using the formula, 2 times 60 times 3 plus 3 square. So I hope you can see that. And 60 square is what? Anybody tell me? It's very easy, right? Because it's, 6 square is 36. You just have to add 2 zeros. 3600 plus 2 times 60 times 3. 2 times 3 is 6. 6 times 6 is 36. Yeah, right? But add a 0 because now you're multiplying by 60. So this is 360. And 3 square is 9. So the answer is 3600 plus 360. How do you add those two? They're a little bit difficult, but you can get it because you can do 36 plus the 100 plus 300 first. You get 3900. Then add a 60, 3960, and then add your 9, 3969. That's your answer. Right? Now I will now show you. This is the normal way. But for some squares, you luck out. There is a nice, I hate to call it a trick, I call it a mathematical property. There's a mathematical property that allows you to calculate the squares without going to these steps, for some of them. So, and for all of them, it's different, but for some of them, it's like you can do it right away. And I'll show you. Have you heard about the squares of numbers ending in 5? I'll show you this. So there is a nice, this is a nice mathematical property that allows you to quickly calculate the square of a number ending in 5. So if you have 35 square, right? 35 square, what you do, any number ends in 5, its square will end in 25. So put 25 here and take the first number, multiply that the next number. So 3 times 4 is 12. 1, 2, 2, 5. You don't have to go through the formula. You can just do this shortcut method. So shall we try another one? Let's try 45 square. Can somebody tell me? That's right. Yeah. Very smart. 2025. So what did I do? 25 here. Multiply 4 by the next number, 5, which is 20. That's it.
Superb, sir.
Now, it's not just 2-digit numbers. You can even do 3-digit numbers. We can try that. Okay. Let's do a 3-digit number ending in 5. Okay. It's not just a 2-digit number. So let's try. I don't know. 125 square. Can somebody try that? I see something 3x plus 125 square. 15625 is correct. Very good. So how did I get it? So 25 comes automatically. I said because any number ending in 5, its square ends in 25. Now take this part. 12 multiplied by the next number. 12 times 13. You know 12 times 12 is 144. 12 times the 13 is 156. 15625. Okay?
Yeah, our kids also like they're putting their calculator to work on this one. Okay.
So I wrote 999 and I wanted to talk about that. That's an interesting pattern also. Sometimes some of these numbers close to 1,000 or 10 or something, they have an interesting pattern. So somebody just wrote 999, maybe I should talk about it. And I think that's also pretty simple. If you have 99 square, it's 9801. And 999 square is just 998001. Okay,
Oh.
and then 9999 square is again this time 3 nines. 998001. Okay, so there are interesting patterns you can make with numbers.
Wow, this is superb, sir. I never knew that like it would be like this one.
Yeah, some of these numbers that are closer to 1,000 or 10,000, they lend themselves to this property. There's a pattern.
Wow, kids, it's amazing, right? We can have this. So I think
this one also, if there are numbers like this, there's one with the all ones, and there are many more patterns. You can come up with your own pattern.
Yeah, sir, like there is one question from us, like how to remember all this thing.
You don't have to remember it. If you have an interest, it just comes automatically.
Yes,
like
yes.
how you play chess. I mean, if you can remember, great. But the idea is you want to develop an interest so that you can actually develop. You can get a feel for how numbers are, right?
Yeah. So like I have one. Sorry for Go ahead, sir. I'll have one.
121. Okay. 111 square. 1 2 3 2 1. 1111 square. 1 2 3 4 3 2 1. 111111 square. 1 2 3 4 5 4 3 2 1. 1 2 3 4 5 4 3 2 1. So this is another pattern.
Superb, sir. Superb. So I have one question from Tej Chura. So he's like, sir, I'm not able to understand 3x you are writing, or like what 3 square? Like I think his question, I'm like, can you find the solution of 3x plus 5 equal to 3x minus 5?
3x plus 5 equals
Like-
3x minus 5. Okay, let me write that on the board. Let me
Like is x square?
3x. Is it an x?
Yeah, that's my question. Is like,
Okay.
I think Tej Surya Bappanna. So can you just
Yes, it
brief
is
that
X.
is X?
It is
X.
X, Naveen. Yeah.
3x plus 5 equals 3x minus 5. Okay. Interesting. This one among integers. Okay, if I bring the 3x here, it's a 0. Yeah, it doesn't have a solution among positive integers or real numbers because you can't solve it. I mean, 3x plus 5 cannot be equal to 3x minus 5, right? Unless you go into imaginary numbers, complex numbers or something. That is my take on it. Because if you bring 3x here, I mean, if you put x equal to 0, it doesn't make sense. So you can't solve it because once you bring 3x here, it's like 0 plus 5 equals minus 5. It doesn't make sense. You have to, I think, have the complex number, the complex plane to solve it.
Yeah. Okay. I understand, sir. Yeah. So, yeah. Yeah, that's like questions appear to be not correct from our side. That's why I wanted to make sure clear from the team. Yeah, it has no solution. Yeah, okay. Got Tej, I think you got solution. Yep. Okay. Sir, can you move for next
Yeah.
step?
Yeah, I don't. By the way, I want to be conscious of everybody's time. So I don't know how much time you have because I was thinking of doing square roots and then large numbers and cube roots and all that. So we'll do it based on that.
Yeah. Yeah, team like Raj sir, like people can also type in the chat. Can we continue the same portion, or you want to add some additional portion on this one?
Yeah, we can continue for another 15 minutes, I think.
Okay.
Yeah.
Let's talk about square roots. Then we'll talk about large numbers. Okay. Square roots, you all know the concept. Okay. Oh, somebody wants to go to big numbers. Okay, let's do that. I mean, I'll mention briefly about square root and then we'll go. So
Okay.
4 square is 16. Square root of 16 is 4. So there's perfect squares. So similarly, 5 square is 25. Square root of 25 is 5. So there's perfect squares and there's imperfect square. So do you know the difference between that? So 25 is a perfect square because it has a perfect square root. But 26 is not a perfect square.
Yes.
You have to estimate it. It goes into decimals. So
Yeah.
we can we can do one. You can take a 2-digit number, square it, and I can take a square root. And then you can give me a random 2-digit number, and I'll take the imperfect square. Random 3-digit, 4-digit number, I'll take an imperfect square. So
87, sir. Now I got it from the 87.
So 87, you want me to square it, is it? Sorry, you take. We want to do square roots now. So
Yeah, square root. Yes.
You want to do the square root of 87, right?
Yes,
okay.
sir.
I can. Yeah, I can. Okay, let me do that. 87 7 square root, right? It is 9.32 or something. Is that the correct answer?
Yeah. Raj sir, we're going to paste the answer. Square.
87 square root, right?
Yeah.
Yes, sir.
$9.32. Okay, how did I do it? Here's what I did. So 87, immediately my mind popped to 8700. Okay, so I had a rough idea. I knew 93 square was 8649 and 92 square was 836. Good thing about square roots, you can sort of linearly interpolate for most part. So I quickly linearly interpolated, and I didn't spend too much time. That's why I only got 2 decimal places. I was able to linearly interpolate and adjust the calculation to basically get. So I basically knew 87 was between 9.3 and 9.4. So linearly interpolated.
Oh, that's a nice trick, sir. Yeah.
So then let's actually move on to because I think we spent too much squares and square roots. Let's then move on to big
Can you
numbers.
have just 2 questions, sir? I'll just have 2 questions in the square root. 47 and 71. 2 questions from them, sir.
Oh, you can ask a bigger number also. You want to do a bigger number for not just 47?
I think I have only 2 questions. That is 47 and 71. If you have somebody has bigger number, can you type in the chat?
I mean, we can do it. It's not a problem. But why don't we do 47? Okay.
Yeah.
Okay. 47 will be. It is 6.8. Sorry, 6.855.
Super, sir.
6.856.
Perfect, sir. Super. Perfect. Yeah.
Okay. How did I get this? I knew 6.8 square. What about 46.24? And remember the thing I told you about 5? You have to just multiply by the next number. So 6.85 square I evaluated. So 6.85 square simply was multiplying 6.8, 68 by 69, 6.8 by 6.9. So I pretty much got 46.9225. And then then again I further interpolated a little bit, and I got 6.855, 6.856.
Okay.
Okay.
Nice, sir. So we have a couple of questions in 3 digits. It is like from Manya 695, sir.
Do you want the square root of 695, right?
Yeah, guys, we're going to take a couple of another 2, 3. Okay. 3 questions last. Okay, 695. Yeah.
It is 26.37.
Yes, sir had just done it perfectly.
What is the answer?
Yes, 26.3628, something like you just rounded. Yeah, that's fine, sir. Perfectly. Yeah.
So what other way I did it? Again, 26 square, 676. I did 26.5 square, which is multiplying 26 by the next number. So I got 26 square equals 676. Then 26.5 square equals 702.25. And then I interpolated a little backwards.
Yeah.
Okay.
Okay, sir. I have another 2 questions. It's 532 and 537. I'm going to go with the 537, sir. Only one is enough because it's the same number, or you want?
Let's just do one because we can go on to the next.
537, sir.
Okay. 537. 5. Let me think. 537. It is 23.175.
Perfect, sir.
Okay. Again, same thing. 23 square was 529. And then I did 23.3, 2 square. I came to close to about 538 something. And I did evaluate the whole thing. And then I interpolated backwards, 23.175.
Superb, sir. So we're going to stop on this portion, and we're going to move for the next portion. So that is the bigger number multiplication. So we have teams. So sorry for that. Like we have a shorter period. Like we have to come.
Yeah, completely understand. I mean, the whole idea is to make this interactive. So I'm going to make. I'm going to give you an interesting problem. Okay, because right now we want to talk about. The idea is not just a show. We want to talk about how numbers become interesting. How do they become big? All right. So, have you all played chess?
Yes, sir.
Great, great. So, when you have chess, and when you play chess, how many squares do you think are there in a chessboard?
64, sir.
64 squares.
Yep.
Okay, perfect. 64 squares. Now, do you know there's a story behind? It's a mythical story behind the invention of chess. So there was this inventor of chess who was very, very happy. He invented this game. Sorry, he invented this game. The king was very, very happy with his inventor, and he asked him, "Give me, you name a reward, and I'll give it to you because this is a lovely game you have invented." So the inventor said, "No, no, it's my pleasure. I don't really want a reward, but it's fine." But the king kept insisting. So finally, he said, "Okay." And again, this is just a story, not that it's true or not, we don't know. So the inventors said, "Okay, fine. Just give me grains of rice, such that you just give me some grains of rice." He said, "Grains of rice? What do you mean? You just want rice? I mean, I thought you will be asking for gold or money or something. Why are you just asking for rice?" He said, "Okay, do it this way. How many grains of rice do you want?" He said, "I want grains of rice such that on the first square, I want 1 grain. Second square, you double, give me 2 grains. Third square, you double 4. Fourth square, you double 8. Fifth square, you double 16, and so on. And then you give me a total number of grains that will cover all 64 squares." The king thought, what kind of a silly request is it? Because just like how small are grains of rice? They're very small. I mean, if you grab it in your hand, you get like thousands of grains of rice. I mean, he thought he'll fulfill the request in no time. But do you know what happened? He couldn't fulfill the request. And we'll use mathematics to figure out how that is the case. Yeah, this is where large numbers come in. So if you have 1 grain of rice on 1 square, okay, You double it on the second square. How many do you have?
2, sir.
Okay. On the third square?
4.
Yeah, somebody actually already mentioned the answer, but let's go over it. Fourth square?
4 square, 16.
8. You go keep on. Then 8. After that?
Oh.
16.
16, yeah.
Then 32.
Yeah.
64.
64.
128. Somebody's typing. Then
Yes.
512. 10. By the time you come to like 10 squares, actually more like the 11 square, it's the sum is actually 2 to the power of n minus 1. But let's keep it simple. By the time you come to 11 square, it's 2 to the power of 10. That's 1024. 2048. 4096. 12 squares. 8192. 16384. 2 to the power of 14. Then 2 to the power of 15. 32768. Then you get to 2 to the power of 16, and I'll write that one. 2 to the power of 16 is 65536. Okay. 65,000 grains of rice. Not too bad, not good, but we only covered 16 squares. Then double it. 2 to the power of 17, 131072. Then 26228, 2 to the power of 18, 6144. 2 to the 19, 524288. Then 2 to the 20, 1048576. So at this point, you have a million grains already. Still, million grains is not bad. You can cover it in a few. Then 2 to the power of 21, 2097152, 22, 404194 Then 2 to the power of 23, 8388608, and so on. Then 2 to the power of 24, 16777 16 million already. 2 to the power of 24, you have 16 million grains, and you only these 24 squares. 16, 2 to the power of 24 is 16,777,216. So this is the sum up to the 24th square, or this is the number of grains on the 25th square, but it's the sum up to the 24th square minus 1. For those of you who are familiar with geometric progression, you will know that the sum up to that place is 2 to the power of n minus 1. But we won't get into complications. So 2 to the 24th square itself, we are 16 million. Now let's keep going. And 2 to the after that, 2 to the power of 25. So 33554432, and so on. By the time you get to 30 squares, okay, 2 to the power of 30, 2 to the power of 30. Do you know how much 2 to the power of 30 is? It is 10737. 41824. That is all. So it's already like you are at 1 billion. 73,741,824. Then 2 to the power of 31. So you're already at 30 squares. You're at 1 billion. 2 to the power of 31 is 21474. 83648, 2 billion. 2 to the power of 32, 4 is already 4 billion at that time. 2 to the power of 32 is 429,496,7296. So it is basically, you're already at 4 billion grains. Okay, it's actually, this is the number of squares on the 33rd, number of grains on the 33rd square, but on the 32nd square, it is 4 billion, so much minus 1. I mean, I won't go to the details of geometric series, but you get the picture. So by the time you get to 32 squares, the sum total is already 4 billion. Now, it keeps on going. 4 billion, it's a lot. You still probably can grow it on the surface of the earth, but let's go forward. By the time you get to 2 to the power of 64, which is the square of this, do you know how big that is? The number of squares, so on the 64th square, you will have 2 to the power of 63. Okay, that is basically 2, 2, 3. This is the number of grains on the 64th. It is 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,808. That's how many grains on just the 64 square. And the sum total is actually 2 to the power of 64 minus 1. I think I'll go to erase that. Okay. Okay. 2 to the power of 64 minus 1. I'll tell you how big that is. 18 quintillion, 446 quadrillion, 744 trillion, 73 billion, 709 million, 551,615. It's actually 616 is 2 to the power 2, but I have to minus 1 because I'm adding the whole thing. This is how big it is. The number of grains is so big that the next day their treasurers were still counting and they hadn't even reached about 30 squares. They think could not fulfill that person's order. Okay.
Yes, sir. Thank you, sir. Like, I think one of our team member, Tej, he's pasted this answer and it perfectly matches to your answer. Yeah, okay. Team, do you have any questions? Like, we're going to close it within 5 minutes because of sir timing and also the programming timing. So, ನೀವು ಯಾವ್ದಾದ್ರು ಕ್ವಶನ್ ಇದೆಯಾ? ಇಲ್ಲಾಂದ್ರೆ ಒಂದಷ್ಟು ಸ್ವಲ್ಪ ಚಾಟಲ್ಲಿ ಹಾಕಿ ಸರ್ ಹತ್ರ ಲಾಸ್ಟ್ ಕ್ವಶನ್ಸ್ ಕೇಳಿ ನಾವು ಸರ್ಗೆ ತುಂಬಾ ಧನ್ಯವಾದ. ಥ್ಯಾಂಕ್ಸ್.
I thought I'd do one more act where I know we didn't get out of time. What I want to do is extract the cube root of a big number. So you give a 4-digit number, and then I need somebody to write the digits for me. I'll come ask my wife to write it on the board. You text it to her on WhatsApp, and then I'll stare at the digits and calculate the cube root of that number. Okay? Cube root of 2-digit numbers I can do, but we've been running out of time, so it's pretty straightforward. I mean, it's not that difficult. 3-digit is much harder. I was also thinking of doing cube root of random cubes, like imperfect cubes, like we did imperfect squares estimating, but we don't have time for that. But I will do the cube root of a 12-digit number or something. Okay, before we finish. But you can do that, or you want to do that first, and then we can close this. However you want to do it.
Like we're gonna do it like we can write it here only, like the questions like.
So what you'll have to do is, because I need somebody to write it on the board because it's a huge number. So I want somebody to take a 4-digit number. Actually, maybe we can just for practice we can just do like give me the maybe like a 2-digit number first, and then we can do a 4-digit number. So maybe somebody can take a 2-digit number and multiply it 3 times. So somebody said 67. You want me to calculate the cube of that? 67 cube is 300,768. But let's do it this way. Take a 2-digit number and then cube it and give me that number, and I'll take a cube root. Okay?
Okay, it's like 493039, sir.
493039 cube root is 79. One more.
17576.
Oh, that is 26. Do you want to try a 3-digit number, cube it, and give it to me?
Yeah. We have a bigger number. It is like 1 2 3 4 5 6 7.
Oh, that's not a perfect cube, right?
Yep. Yeah, perfect.
I'll take an imperfect cube. Well, what is the number you said?
It's just 1 2 3 4 5 6 7.
1 2 3 4 5 6 7. Okay, it's an imperfect cube. So let me do that. It is about 107.1. I may be a little bit off. The imperfect cube roots are hard. Is that right? 107.1. You can take a calculator and do the cube root function.
Yeah. And yeah. I think like somebody is doing sir background. So can we go for the next question, sir?
Yeah,
We're going to close
take
it
a
like.
three-digit number and cube it and give me the cube. Take it, do a perfect cube.
Okay, sorry. I have two numbers, which is from Arjun Chandrapa. It is 967361669.
Okay, that's okay. The 967.
Yep.
Sorry.
Nine six 967.
Yeah, you don't mind if I write. You know what? Let me write this. It's a
Yeah. That's fine, sir. You don't need to blind find. We are.
Yeah. Okay. Let me write this. It's a lot easier because. Yeah. So what did you say it was?
967361669, sir.
1669. So you want to take the cube root of this one, right?
Yeah.
989.
Okay. Correct, sir. Perfectly. Okay, guys.
You want to do a 4-digit number. For that, I'll have to call my wife because I can't write so many digits.
Yeah. Okay, sir. We're gonna hold this show for this. Like we have a very time consume. Like we're gonna. Thanks for really your time, sir. We enjoyed. Like our kids are so much curiosity, and sorry for holding you on this time. And everybody's excited. Like if you send chat, awesome. They liked it, and they're going to share your YouTube's like channel or anything. We're going to subscribe it. Please send us, and after this meeting, we can subscribe it. And any opinion or anything.
You want to do just one last the 4-digit one? We thought about it.
Yep.
Yeah, I'll call my wife so that she can write the digits on the board.
Yeah. Please, sir. Go ahead. Please go ahead.
Okay. So pick a 4-digit number and text it to her, or and then she can write it on the board. Okay.
Yeah. Raj, sir, you have to like.
Okay.
You could go ahead, sir.
She can write it. So she will write the number on the board for me and. For that. Yeah, write it on the board. I'll blindfold myself, and when I'm ready, just I'll take that. Yeah, they'll WhatsApp it to you.
Sure. Yeah. So if as soon as I get the 4-digit number, I think it's the cube of 4-digit number, right?
Yes.
Yeah.
Yes. Did we? Okay. So it's an imperfect cube, right?
No, it's a perfect cube. So take a 4-digit number, cube it, and give it to me.
Okay, I'm typing now.
And I mean, text it to Soumya, and she will write it.
Yeah.
Yeah.
Do I need to say the number?
No, I'll just tell me when it's ready. I'll just take the cube. It's hard because it's.
Can you guys see it?
Yeah, we can see it, ma'am.
Okay. Shall I open the blindfold?
Yeah.
Okay.
Yes.
All right. So the number here is okay. All right. So let me see.
Did I write it correctly?
Did
I write it?
I hope it's okay.
Yeah.
I'll try. Okay. Okay. This is the correct number, right?
Yes.
All right. So this is. I hope I get this right. 2, 3, 5, 6.
Is that right, Arjun?
Arjun, you can type in answer. Waiting for your answer.
I think I did not do that.
1 second, sir.
think I can do that.
Yeah, you can.
Yes, sir. I think.
Perfect, sir.
Is this the right answer?
Yes.
Correct. Yeah.
Yeah, he's right, correct.
Okay. So just for the audience, thank you, Soumya. The number was 130775344, and the cube root of that was 2356. Okay. Thank
Okay,
you.
sir.
Okay. So
Awesome, sir.
thank you, and go ahead, Navi.
Yeah, thank you very much. Like everyone liked, and it's a very inspiration for the kids, and they loved it, and they enjoyed this show. Like they'll continue. This is like for us is an habba for knowledge, maths, and lot of you can see that a lot of you say like inspiration like a Shakuntala Devi. So you were like for us. We never seen her, like we may see it in some videos, but now this is the first time we had a live interactive, and this is very nice, and thanks for your time and sharing your knowledge to us. Hopefully when we have a live interactions, like when we have, so we'll try to invite you. If you could join, that will be great help. That time we will be like more questions, they understand how this works, and they might be come up with some different questions for you. And so we gonna end this program, so please continue. Gonna be have a next program is called Dumb Charad from that will be hosting by Harish. Okay. And anything, sir, any Raj or Mukta ma'am, you want to add anything for here?
I want to add something. Just I forgot to mention this. Just FYI, everyone. This is recorded, and I think you already sort of knew that because you see the recording sign. So I hope it is all okay with you all if I put this on social media or something. Unless somebody has like a major objection, my plan is to just put this on social media like Facebook or YouTube or something. I hope that is okay with everybody.
Thank you, sir.
Shiva sir, sorry. I think there was an ask in the chat to share your channel name on YouTube. So if you don't mind, so the kids can follow and subscribe.
Sure. I don't have the channel name, but you can search for my name, Siva Natarajan, my first name and last name, and you'll find a lot of videos on pi. I have done pi recitations, etc. Unfortunately, some were on Facebook. The latest one with 10,000 digits was on Facebook. It is not on YouTube, but yeah, that's great. And you'll find mental math shows and pi shows, etc. So just search for it, and you are welcome to subscribe it. No concern. I don't have the URL in front of me right now, but feel free to search for it in YouTube.
Okay, awesome. So I hope for those who asked for it, I hope that answers your question there.
Also, one of them have asked if there is a book that you could recommend for the kids.
There are lots of books on. I mean, if you are just wanting to learn mental mathematics, there are. I'm sure there are lots of books. There are lots of methods like Trachtenberg system of speeding math, and there's a lot of links on the internet. There's Vedic mathematics, etc. But then again, they're all out there. It's then the abacus system. So whatever you can, whatever works for you, that is what I would go with. I don't use a specific book or anything. I just do it because I just like to do it. It just comes more like I just started doing it. So I'm not aware of specific books. I mean, there are books out there. So just look at the internet. I don't want to recommend one book or the other, but there's many out there. Just my basic thing is just develop an interest in numbers. That's all.
Yeah, thank you all. Do you have we're going to end this show once again. Thanks, sir. Thanks for coming, and we're going to continue with the next program. Because of time constraint, we need Raj sir. We're going to be having a Dumb Charad or Antakshari.
Naveen, I think Mukta auntie will go next, and then yeah, go ahead, Naveen.
Yeah. So Mukta auntie, can you just share your screen and start share your comments?
Okay. Well, and first of all, and thanks everybody for listening in. I hope you enjoyed the show, and thank you Naveen and Raj and the Hoysala Kannada Sangha Association of Delaware for organizing this and having me over. Thank you.
Thank you very much, sir. ಧನ್ಯವಾದಗಳು.
Unless you have any questions, I'm going to drop.
No questions. I can drop off. Thank you. Thanks for joining.
Can you wait for some more minutes? Few more minutes, sir.
Yeah.
Yes, sir. Yeah. Thank you.
Certainly.
Yeah, I think that's better.
Yeah. Good point, sir.
ನಮಸ್ಕಾರ ಎಲ್ರಿಗೂ. ಕರ್ನಾಟಕ ರಾಜ್ಯೋತ್ಸವ ದೀಪಾವಳಿ ಹಬ್ಬ ಮತ್ತು ಮಕ್ಕಳ ದಿನಾಚರಣೆಯ ಶುಭಾಶಯಗಳು. ಈಗ ನಾನು ಇಲ್ಲಿ ಹಾಕಿದ್ದೇನೆ ಅಂತ ನೀವೆಲ್ಲ ಕೇಳ್ತಿರ್ಬೇಕು. ಇಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಇರಬೇಕಾದವರು ಅಂದ್ರೆ ಹೊಯ್ಸಳದ ಅಧ್ಯಕ್ಷ ರಾಜಲಕ್ಷ್ಮಣ್ ಕುಲಕರ್ಣಿ ಅವರು. ಇವತ್ತು ಅವರಿಗೆ ಕೆಲಸದ ಒತ್ತಡ ತುಂಬಾ ಆಗಿದೆ. ಇಲ್ಲಿ ನಮ್ಮ ಜೊತೆ ಮಾತಾಡ್ತಿದ್ದಾರೆ, ಹಾಗೆ ಕೆಲಸನೂ ಮಾಡ್ತಿದ್ದಾರೆ. ಅವರು ಮಲ್ಟಿ ಟಾಸ್ಕಿಂಗ್ ಪರ್ಸನ್. ಸೊ ಅದಕ್ಕಾಗಿ ಅವರು ಈ ಟೈಮು ನನಗೆ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಸೊ ಅದಕ್ಕಾಗಿ ಕ್ಷಮಿಸಿ. ಆಮೇಲೆ ಈಗ ಈ ದಿನ ಇವೆಲ್ಲರೂ ಇಷ್ಟೆಲ್ಲ ಟೈಮು ಸ್ಪೆಂಡ್ ಮಾಡಿ ಎಲ್ಲ ಕೆಲಸ ಬಿಟ್ಟು ನಮ್ಮ ಜೊತೆ ಎಲ್ಲ ಕೂತು ಈ ಎಲ್ಲ ಕಾರ್ಯಕ್ರಮ ತುಂಬಾ ಆಕ್ಟಿವ್ ಆಗಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡಿ ಎಲ್ಲ ಮಾಡಿದ್ದೀರಾ. ತುಂಬಾ ಧನ್ಯವಾದಗಳು. ನೀವಿಲ್ದೆ ಈ ಕಾರ್ಯಕ್ರಮ ಎಂದು ಇರ್ತಿರ್ಲಿಲ್ಲ. ಆಮೇಲೆ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟು ಅಂದ್ರೆ ಡಾಕ್ಟರ್ ಶಿವ ನಟರಾಜನ್, ನೀವು ನಮ್ಮ ಮಕ್ಕಳಿಗೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಬಿಟ್ಟು ಬಿಡಿ, ಹ್ಯೂಮನ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಆಗ್ಬಿಡಿ ಅಂತ ಒಳ್ಳೆ ಪಾಠ ಕಲಿಸ್ತಿದ್ದೀರಾ. ಐ ಹೋಪ್ ನಮ್ಮ ಮಕ್ಕಳೆಲ್ಲ ಇದನ್ನ ಕಲಿತಾರೆ ಎಂದು ಮುಂದೆ ವರ್ಸ್ಕೊಂಡು ಹೋಗ್ತಾರೆ. ಹೇಗೆ ಮ್ಯಾಥ್ ಮಾಡಬೇಕು, ಮೆಂಟಲ್ ಮ್ಯಾಥ್ ಹೇಗೆ ಮಾಡಬೇಕು ಅಂತ. ಸಾರಿ, ನಿಮ್ಗೆ ಟೈಮು ಕನ್ಸ್ಟ್ರಿಕ್ಷನ್ ತುಂಬಾ ಇತ್ತು. ಇನ್ನೊಂದ್ ಸರ್ತಿ ಬರೀ ನಿಮ್ದೇ ಪ್ರೋಗ್ರಾಮ್ ಇಟ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ ಅಂದ್ರೆ ತುಂಬಾ ಒಳ್ಳೇದಿರುತ್ತೆ. ನೀವು ನಿಮ್ಮ ವೈಫ್ ಇಬ್ರು ಬಂದು ಪ್ರೋಗ್ರಾಮ್ ಕೊಟ್ಬಿಡಿ, ಅಂದ್ರೆ ಮಕ್ಕಳು ಲೈವ್ ಆಗಿ ಇಂಟ್ರಾಕ್ಷನ್ ಮಾಡಿದ್ರೆ ತುಂಬಾ ಚೆನ್ನಾಗಿರುತ್ತೆ. ಆಮೇಲೆ ನಮ್ಮ ಸಮಾರಂಭಕ್ಕೆ ನೀವು ನಿಮ್ಮ ಗಿಟಾರ್ ತಗೊಂಡ್ಬನ್ನಿ, ಹಾಡಿ ಎಂಜಾಯ್ ಮಾಡಿ. ನಮಗೂ ಸಂತೋಷ ಆಗ್ಲಿಕ್ಕೆ ಇದು ಕೊಡಿ, ಟೈಮ್ ಕೊಡಿ. ಸೊ ತುಂಬಾ ಧನ್ಯವಾದಗಳು. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ರಿ ನೀವು. ಆಮೇಲೆ ನೀವೆಲ್ಲ ಮಕ್ಕಳು ಇವತ್ತು ಎಷ್ಟೊಂದು ಇಂಟ್ರಾಕ್ಟಿವ್ ಆಗಿದ್ದೀರಾ. ಸ್ಕೂಲ್ನಲ್ಲೂ ಹೀಗೆ ಇಂಟ್ರಾಕ್ಟಿವ್ ಆಗಿದ್ರೆ ಎಷ್ಟು ಚೆನ್ನಾಗಿರುತ್ತೆ ಅಂತ ವಿಚಾರ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಿಮ್ಗೆಲ್ಲ ಇಷ್ಟೆಲ್ಲ ಡಾನ್ಸು, ಹಾಡು, ಆಮೇಲೆ ಶ್ರೇಯನ್ ಇದು ಎಲ್ಲ ಪಿಕ್ಚರ್ಸ್ ಎಲ್ಲ, ಡ್ರಾಯಿಂಗ್ಸು ಎಷ್ಟೊಂದು ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದಾರೆ. ಐ ವಾಸ್ ವೆರಿ ಇಂಪ್ರೆಸ್ಡ್. ತುಂಬಾ ಧನ್ಯವಾದಗಳು ಶ್ರೇಯಾ ಮತ್ತು ಎಲ್ಲ ಮಕ್ಕಳು, ಡಾನ್ಸ್ ಮಾಡಿದ ಮಕ್ಕಳು, ಹಾಡಿದ ಮಕ್ಕಳು ಎಲ್ಲ. ಆಮೇಲೆ ಈ ಕಾರ್ಯಕ್ರಮದ ಸಂಘಟಕರು ಯಾರ್ಯಾರು ಅಂತ ನೀವೆಲ್ಲ ವಿಚಾರ ಮಾಡ್ತಿರ್ಬೇಕು. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ದಾರೆ. ಅವರೆಲ್ಲ ಹೆಸರು ಮೊದಲೇದವರು ಅಂದ್ರೆ ರಾಜ್ ಲಕ್ಷ್ಮಣ್ ಕುಲಕರ್ಣಿ, ವೀಣಾ ಲಕ್ಷ್ಮೀನಾರಾಯಣ್, ದೀಪಕ್ ಬುಡಗಪ್ಪೆ, ಉಮಾ ಭಟ್, ನೂತನ್ KS, ಸ್ಮಿತಾ ತಂಡೇಲ್, ನವೀನ್ ಕುಮಾರ್ ರಾಯಚೂರ್, ಶಿಲ್ಪಾ ಮುದ್ಗಲ್, ಯಶಸ್ವಿನಿ ನವೀನ್ ಕುಮಾರ್, ಹರೀಶ್ ಪರಪ್ಪ, ಚೇತನಾ ಶಿವಮೂರ್ತಿ. ಇವರೆಲ್ಲ ತುಂಬಾ ತೊಂದರೆ ಪಟ್ಟು ಈ ಕಾರ್ಯಕ್ರಮ ನಮ್ಮ ಮುಂದೆ ತಂದಿದ್ದಾರೆ. ಇವರ ಅವಿರತ ಕಾರ್ಯಕ್ಕೆ ಧನ್ಯವಾದಗಳು. ಆಮೇಲೆ ಈ ಕಾರ್ಯಕ್ರಮದ ನಿರ್ವಾಹಕರು ನೀವು ಕೇಳಿದ್ರಲ್ಲ ಎಲ್ರು, ಸ್ಮಿತಾ ತಂಡೇಲ್ ಮತ್ತು ನೂತನ್ KS ಅವರು ಎಷ್ಟು ಚೆನ್ನಾಗಿ ಮಾಡಿಬಿಟ್ರು. ನನಗೆ ಇವ್ರ ಮುಂದೆ ನನ್ಗೆ ಶೇಮ್ ಆಗ್ತಾ ಇದೆ, ಎಷ್ಟೊಂದು ಚೆನ್ನಾಗಿ ಕನ್ನಡ ಮಾತಾಡ್ಬಿಟ್ರು ಅಂದ್ರೆ. ನೂತನ್ ಅವರೇ, ನೀವು ನಮ್ಮ ಕನ್ನಡ ಶಾಲೆಗೆ ಶಿಕ್ಷಕರಾಗಿ ಬಂದಿದ್ದು ಒಂದು ತುಂಬಾ ಹೆಮ್ಮೆಯ ವಿಷಯ. ನಿಮ್ದು ಮಂಕುತಿಮ್ಮನ ಕಗ್ಗ ಕೇಳಿ ಖುಷಿ ಆಯ್ತು. ನಿಮ್ಮೆಲ್ರಿಗೂ ತುಂಬಾ ಧನ್ಯವಾದಗಳು. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಕೂಡ ಹೀಗೆ ಎಲ್ಲ ಇದು ಸಾಗಿಸ್ಕೊಂಡು ಹೋಗ್ತೀರಾ ಅಂತ ನನ್ನ ವಿನಂತಿ. ಆಮೇಲೆ ಇದಕ್ಕೆಲ್ಲ ಅನುವು ಆಗುವಂತೆ, ಸಾಧ್ಯವಾಗುವಂತೆ ಮಾಡಿಕೊಟ್ಟ ಕನ್ನಡ ಹೊಯ್ಸಳ ಸಂಘಕ್ಕೆ ನಮ್ಮ ಅನಂತ ಧನ್ಯವಾದಗಳು. ಇಷ್ಟೇ ಅಲ್ಲ, ಧನ್ಯವಾದ ಅಷ್ಟೇ ಅಲ್ಲ ನನ್ನ ಕೆಲಸ. ನಾನು ಇನ್ನೊಂದೇನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ, ನೀವು ಎಲ್ಲಾರು ವಾಲಂಟಿಯರ್ಸು ಫಾರ್ಮ್ ತುಂಬಿ ಸೈನ್ ಮಾಡಿ ಕಳ್ಸಿದ್ದೀರಾ. ಹೀಗೆ ಕಳಿಸ್ತಾ ಇರಿ, ಬೇರೆ ಬೇರೆ ಜನರಿಗೂ ಪ್ರೋತ್ಸಾಹ ಮಾಡಿ ವಾಲಂಟಿಯರ್ ಆಗ್ಲಿಕ್ಕೆ. ನಮ್ಗೆ ಜಾಸ್ತಿ ವಾಲಂಟಿಯರ್ಸ್ ಬೇಕು. ಸೊ ಎಲ್ರಿಗೂ ಸ್ವಲ್ಪ ಹೇಳಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೆ, ನಿಮ್ಮ ಫ್ಯಾಮಿಲೀಸ್ಗೆ ಎಲ್ಲರೂ ವಾಲಂಟಿಯರ್ ಆಗಿ. ಇದು ಹೊಯ್ಸಳ ಸಂಘದ ವತಿಯಿಂದ ನನ್ನ ವಿನಂತಿ. ಓಕೆ, ನಮಸ್ಕಾರ. ಮತ್ತೊಮ್ಮೆ ಕನ್ನಡ ರಾಜ್ಯೋತ್ಸವ, ದೀಪಾವಳಿ ಮತ್ತು ಮಕ್ಕಳ ದಿನಾಚರಣೆಯ ಧನ್ಯವಾದ, ಶುಭಾಶಯಗಳು. ನಮಸ್ಕಾರ.
Yeah. Thank you, sir. Thank you, ma'am. Sir. Thanks, everyone. ಎಲ್ಲರಿಗೂ ಒಂದ್ಸರಿ ಧನ್ಯವಾದಗಳು ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಬಂದಿರೋದಕ್ಕೆ. ನಾವೆಲ್ಲ ನೋಡಿದ್ವಿ, ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ನೋಡಿದ್ರಿ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನ. ಮತ್ತೆ ಮುಂದಿನ ಕಾರ್ಯಕ್ರಮಗಳಲ್ಲಿ ನಾವೆಲ್ಲ ಮತ್ತೆ ಸೇರೋಣ. ಎಲ್ಲರಿಗೂ ಒಂದ್ಸರಿ ಧನ್ಯವಾದ. ಕನ್ನಡ ರಾಜ್ಯೋತ್ಸವ ಶುಭಾಶಯಗಳು. ಜೈ ಕರ್ನಾಟಕ. ಸಿರಿಗಣ್ಣನ್ ಗೆಲ್ಗೆ. ಥ್ಯಾಂಕ್ ಯು.
Thank you.
Thank you, sir.
Thank you. Take care. Thank you.
Thank you.
Thank you, Naveen.